What is going on, guys? Welcome back. In this video today, we're going to learn how to properly evaluate RAG systems in Python using a package called Ragas. I think that's how it's pronounced. Basically, what it allows us to do is it allows us to evaluate the quality of LLM responses that are based on context. So when we do retrieval augmented generation, we retrieve context, we answer the questions based on the context in the optimal scenario. And this package allows us to evaluate the quality of responses, and it does that in a way that also incorporates large language models. Because of course, it's very difficult to just apply some basic deterministic mathematical formula to this. But also, you don't want to have like a fuzzy metric like overall, does it sound fine or not? You want to have some concrete stuff that you can express in numbers, but you want to keep it flexible because these responses themselves are dynamic and flexible. So this is exactly what the Ragas package does for us. So let us get right into it. Alright, so we're going to take a look at Ragas in this video today, and for this video I already have a Jupyter notebook prepared that we're going to go through. I think you're going to get more value out of this video if we do it that way instead of me typing out the code for half an hour and then talking about it in between. So what I'm going to do is I'm going to give you a link in the description down below where you can download this notebook, you can run it on your own system, you can play around with it, and I'm just going to explain here what the individual lines or individual cells here do and why this is relevant, why this package is useful in production in various projects. So first of all, before we get into any of the theory or into any of the topics here, I want to show you how you can set this up. So you want to open up your terminal, you want to type pip or pip3 install, and then Jupyter Lab is a single word. So pip install Jupyter Lab or pip3 install Jupyter Lab. You install this, then you go into a directory and you run Jupyter space lab. So Jupyter white space lab. This is going to open up a Jupyter Lab instance in your browser. You probably want to set this to dark mode. You probably also want to enable Vim key bindings if you use them. And then you basically have the exact same setup. Just make sure you have the IPYNB in the directory that you're running this in. And then you can just open up the notebook and try it yourself. Of course, you also need a couple of dependencies installed. For that, again, open up the command line and type pip or pip3 install. As you can see here, we're using face, either face CPU or face GPU. We're using OpenAI, so pip install OpenAI as well. We're using .env, which is Python -.env, and we're also using down here data sets. So this is a transformers or a Hugging Face package, just pip install data sets. Then also, of course, Ragas, and then also, of course, the LangChain stuff. So LangChain Ollama, LangChain community. If I don't forget about it, you're just going to get a requirements.txt in the GitHub, and then you can just do pip or pip3 install -r requirements.txt. Besides that, I hope you are experienced enough to just manage all the dependencies and all the issues that arise. Just Google or ask your favorite large language model and you're going to get the instructions. So let's get now to this tutorial. Let's get to Ragas. Now, the first part of this notebook is not about Ragas, and it's also optional. You don't need to do it that way if you just want to play around with the evaluation in and of itself. But what we do here is we set up an actual RAG system. So what we have here is we have a couple of documents, which is our knowledge base, so to say. We have stuff like Paris is the capital of France. Then Jane Austen is the English novelist best known for Pride and Prejudice. Then the Great Wall of China, then Mount Everest. And then we have like this custom information that I add here. Mike loves the color pink more than any other color. So the idea is we have a RAG system. This is now just for showcasing the functionality. The idea is we have then a large language model. In this case, I'm using for the embedding here, the text embedding 3 small model. And for the question answering, I'm using GPT-4o. And the basic idea is we're asking a question, and what it does in order to answer the question is it retrieves context that is relevant and answers the question. Now, this is a basic RAG system. This is not what this video is about today. The question is, how do we evaluate it? So let's say my model gives me an answer. I ask a question, I get an answer, and the model also, in order to give that answer, retrieves context. So what I'm interested in is, first of all, how accurate is the answer? How correct is the answer? How fitting is the context, which means how much is the answer actually based on the context, because it can be the correct answer, but the context can be garbage. So for example, I could be asking something like, what's the capital of Paris? the context is that Mike's favorite color is pink, and it tells me that the, or actually did I say capital of Paris? I said I wanted to say capital of France. Then it tells me it's Paris, but the context is Mike's favorite color is pink. So the retrieval is garbage, but the answer is correct. So there are different metrics for that, but the question is, how do we evaluate that? Because with dynamic responses like these, or this is the context, but with dynamic responses like produced from large language models, it's not that easy to just apply a formula. So what we do is we employ additional large language models to give us metrics, to give us data to count certain things, to evaluate certain things, and to then give us these raw numbers, and then we can apply a formula to get certain metrics. We're going to see how this works in a second. But so that you understand the setup, we have this context here, or this database full of context. Then we have a client, which is the embedding client in this case. What we do here is we get a an embedding for some input text. So this is just a function that takes in some text, a question or some piece of information, some context, and it embeds it into vector space. For those of you who don't know how this works, basically you have a vector store, a database that stores vectors, and these vectors are not 2 or 3 dimensional. They're oftentimes 1000 dimensional, 4000 dimensional, and usually it's powers of 2, so 4096 or 1024. And this is the dimensionality of the vector space, where we take some text and we embed it into this vector space, which means I take something like Mike loves the color pink more than any other color, and the embedding places that into a vector space with dimensionality 4096, which means I get 4096 numbers, which is basically the coordinates of that information in vector space. And the idea is, if the embedding model that we use here is intelligent, it's going to place similar instances, similar information, similar texts closer together than completely dissimilar texts. So the idea is, when I ask what is Mike's favorite color, that this is going to be pretty close. The embedding of that question is going to be pretty close to this information. It's going to retrieve that and give me the answer. That's like the very basic high level explanation of how RAG works. And this function here just creates the embedding and returns it, nothing more. Here what we do is we add the context, so we add the documents to a vector store. Face is just a vector database from Meta, I think. We just take the embeddings, we get them from all the docs, and we just add them to the index. The index is the vector store. That is what we do here. And then we have this function retrieve. What it does is it gets the query, which is the question of the user. It embeds that and also performs a similarity search in the database. So it gets the embedding and gets the k most similar or most relevant pieces of information and returns them. So this is what happens here. We get the pieces of information that are the most relevant. For example, I could be asking, Mike was recently traveling to Europe and he also has a favorite color. Which one is it? I don't know. Then probably the 2 most relevant pieces of information are going to be this one and this one, Paris and the color pink. So this one is not going to be important for the question, but this one is going to be important. So it's going to take that and tell us the color is pink, for example. And this now here finally is just the generate answer function. Answer the user question only with facts found in the context. Then we provide the context that we retrieve here, and then we answer the question. So we provide, of course, also the question, then we get an answer. This is what the large language model produces. Up until this point, nothing has to do with Ragas. This is just us building a RAG system, a very, very basic RAG system. Ragas is now all about evaluating that RAG system. So about saying how well does it perform, how faithful are the answers, how correct are the answers, how relevant are the answers, and how well was the context chosen, for example. So now we get into the evaluation. What we do for this is we craft a data set. So what we do here is we have, we import from datasets the dataset class just so we can create a data set. And what we do is we formulate a couple of questions. What is the capital of France? Who wrote Pride and Prejudice, and so on? And then also, what is Mike's favorite color? Then we have the so-called ground truths, or the reference as it's called in the data set. And this is just the answer. This is just the correct answer. Paris, Jane Austen, the Himalayas, and pink. These are the correct answers to the questions here in the correct order. And what we do now is we just iterate over them, we zip them together, we iterate over them, and we then say that the context, so here we actually already do the inference. We say, give me the context, give me the 2 most relevant pieces of information given that question. then generate an answer with that context. And then what we do here now, this is our data set that we want to use for evaluation. We provide for the evaluation process the question that was asked, the context that was retrieved, the answer that was given by the large language model, and then the ground truth, what we expect to actually be the correct answer. So with that information now, we craft a data set from this list. So we craft a data set and then we pass this to Ragas. So here from Ragas, what we do is we import the evaluate function and a couple of metrics. We have the answer correctness, the answer relevancy, the faithfulness, the context precision, and the context recall. So I have links down here for each of the metrics that you can take a look at. We're going to do that here in a second. But essentially, the correctness is how correct is the answer. The relevancy is how relevant is the answer. Faithfulness is, I think, how close or how much it's based on the context. I think that is what faithfulness is. Measures how factually consistent a response is with the retrieved context. For example, if my context tells me that Mike's favorite color is green, and the model says that the color is pink, the answer is 100% correct, but the faithfulness is very low because it did not answer based on the context. So the faithful answer would have been Mike's favorite color is green. The correct answer is it's pink. So these values don't have to be necessarily correlated. So they are not necessarily correlated. Oftentimes they are, but I can have, for example, wrong context be very faithful to that wrong context. That would make my answer incorrect, but it would make the response very faithful. And for each of these metrics here, you can just click on the links and you can see how they are calculated. For example, faithfulness here has an actual formula, which is the faithfulness score is the number of claims in the response that is supported or that are supported by the retrieved context divided by the total number of claims in the response. Now, of course, you notice already this is not something that can be really expressed as an algorithm. I mean, number of claims. How do I get the number of claims? Well, you do that with another large language model. You ask a large language model that you trust to be competent enough to give you the correct answer. How many claims does this response make? For example, the response could make something like a claim like Mike's favorite color is pink, Mike's favorite food is pizza, and Mike's job is programmer. Then the question is how many of these claims are backed by the context provided, and that would give us the faithfulness score. And of course, as I said, the retrieval or not retrieval, but the number of claims, the number of total claims and the number of supported claims, this is something that a large language model has to just tell us. We have to believe it. So of course, it's not a perfect mathematical formula, but all of these are in some way formulas that have to be used or that have to be based on large language models giving us the correct data. So yes, this is a mathematical formula that we can just calculate, but total number of relevant items, this is something that the large language model has to tell us. We cannot just calculate this. That is the idea of Ragas. We use LLMs to evaluate LLMs. So how do we do that? Very simple. We have the evaluation data set that I just explained here, that I just crafted. And then I pass it here and I say, these are the metrics I want to calculate. That's it. That's exactly it. So I think I need to run this because my previous inputs are no longer here. So basically I have all of this here and I run this cell here and this is going to give me the scores. By the way, what's important, I'm loading up here the .env file. What does this mean? This doesn't work on your system out of the box because what you need to do is you need to provide a .env file, a file called .env. So basically if I go to this is now in my prepared directory. So what is it called? I think I called this Ragas, right? Here I have a file called .env, like this, .env. And in this file, I have an OpenAPI key, an OpenAI API key. So basically, I'm not going to open the .env file now, but I'm going to open an env file. I have a line in there saying OpenAI underscore API underscore key is equal to, and then whatever the OpenAI API key is, and that is going to be loaded automatically. So of course you need to connect to your OpenAPI. How often am I going to say OpenAI API account, and you need to provide the key. You need to also probably spend a couple of cents on this, maybe 1 or 2 cents to do all of this, but you need to have a connection to an API. So here now the evaluation is done. It says question, what is the capital of France, context, Paris is the capital and most populous city of France, and so on. Then it has here all the context, all the responses, all the ground truths, and it tells us on average here, this is now aggregated over all the questions, all the responses, all the contexts. The answer correctness is 97%, the answer relevancy is 99%, the faithfulness is 100%, the context precision is 100%, and the context recall is also 100%. Pretty good values. And what I want to do now is I want to play around with this a little bit and see how we can force certain outcomes. So we're not going to let the LLM do anything or everything, we're going to do it ourselves. So here now I have an example where we get the high scores. And in this particular example, we're only focusing on Mike. So very similar as above. The only difference here is we're only using the context for Mike. We're only using the question about Mike, and we're only giving the ground truth about Mike's favorite color. So I'm going to run this, and what I'm going to get here is just this one single instance evaluated. And then I should probably get a pretty high score. There you go. What is Mike's favorite color? Retrieved context. Mike loves the color pink more than any other color. Response. Mike's favorite color is pink. Reference pink. Great. Very high values here because this is correct, this is relevant, this is consistent, everything's fine. Here now we're going to pass the wrong context, but we're still going to, we're going to pass the wrong context and we're going to let the LLM generate a response. So what's going to happen here is I'm passing the context. Vienna is the capital of Austria, which is not telling us anything about Mike's favorite color. So I'm going to just run this now, and the LLM is probably going to guess blue because when you don't provide anything, it always says blue or it says, I don't know. In this case, it says the context does not provide information about Mike's favorite color. So interesting here is the answer correctness is very low, 19%. So it's not pink. The answer is not pink. The answer relevancy is also very low because it didn't really answer the question. Faithfulness is very high. Why? Because we don't make any claims. We don't make the claim that Mike's favorite color is something. So that is very faithful to the context. So we don't actually make any claims, and no claims are supported by the context. Context precision is very low because basically this is useless context. Who cares about this if I'm asking about Mike's favorite color? Context recall, same thing. So down here now, we can see that these values don't have to go hand in hand with one another. Here I'm providing the same context. Vienna is the capital of Austria. But this time what I do is I provide, statically coded here, I provide the response that Mike's favorite color is pink. So I'm hard coding the response. I'm giving the true answer without having the context. So now when I run this, we're going to see that the answer correctness is going to be very high because we're giving the correct answer. There you go, 96. The answer relevancy is also very high because the answer is relevant to the question. The faithfulness is 0. Why? Because I'm making a claim that is not backed up by the context. By the way, I should probably move this up here. Context precision, same thing, context recall. The context is useless. The answer is not based on the context. This is what we see here, but the answer is relevant and correct. That is how you can interpret the various metrics. And of course, there are also different metrics here. So you can take a look at all of them in the documentation. And finally, I want to show you one more thing, which is Ollama integration. Now, Ollama, for those of you who don't know what Ollama is, it's a tool that allows you to run large language models locally. In my case here, I have a bunch of them installed. And what I can do now is I can just go into the code using LangChain, and I can select one of them, for example, Qwen3, 4 billion parameters. I can say here, from Ragas, still import, actually that's duplicate, we don't need that. From Ragas.llm, import LangChain LLM wrapper. From Ragas embeddings, import LangChain embeddings wrapper. Then from LangChain Ollama, actually, let me make this larger. From LangChain Ollama chat models, import chat Ollama. And from LangChain community embeddings, import Hugging Face BGE embeddings. So what we do here is we say the LLM I want to use for the evaluation, for the answering of the question and so on, that is going to be, or actually in this case, just for the evaluation. The LLM I use for that is chat Ollama, which means I'm going to use a local model. In my case, Qwen3, 4 billion parameters, temperature set to 0, so very strict and boring and kind of deterministic. And then to use it in Ragas, what I do is I say, Ragas LLM is equal to LangChain wrapper around this LLM. So I create the LLM using chat Ollama. I then make it compatible with Ragas by using the wrapper. Then I do the same thing with the embedding model. I load it from Hugging Face, this one for example. Then I wrap it around this LangChain embeddings wrapper so that I can use it in Ragas. And then I just do the same thing on the same data. So I can, actually I need to run this first, then I can run this. And then hopefully it's not going to crash my system while I'm recording because it uses a lot of GPU resources. So hopefully that works. And it's going to take some time because my computer is a bit slow. I have a 3060 Ti. It's not the best GPU on the market. I have 8 gigabytes of VRAM, so probably stuff is going to lag a little bit. But once you have the evaluation, that is exactly the same thing as before. You're just using probably a less capable model, and depending on your resources, you can actually use a quite competent model. But that is like how you could use that in a setup where you have your own on-premise models or your own servers, or you're renting some cloud resources and so on. That is the same process, just with open source models. Okay, I tried it now for quite some time. I'm not going to do it now for the video. You can see that it produces a result. It's not a problem with the code. It's a problem with my setup, with my GPU, with Ollama and everything. But this is how you do it. And maybe I'm going to put in some screenshot, or maybe when you download the notebook, you're going to see the results here. But essentially, if you have a capable model, this should have a very similar result. You can also use this with Ollama. So that's it for this video today. I hope you enjoyed it and hope you learned something. Make sure to hit the like button and subscribe to this channel. Make sure to also hit the notification bell. Let me also know in the comment section down below if you guys enjoy RAG, large language model, AI, machine learning content, because on this channel I oftentimes mix stuff around. I do Python tutorials, I do backend development, I do deployment, I do algorithms, I do machine learning, but in general, Neural 9 is actually focusing on machine learning. At least that was the plan in the beginning. So let me know in the comment section down below what kind of videos you enjoy the most. And also, as I said, don't forget to subscribe. It helps the channel. So other than that, thank you much for watching. See you in the next video, and bye.